Okay.
I have a question on this.
Yeah.
Is it harder than what we've been doing, or is it?
For what, this?
Yeah.
It's very similar to what we did with the square root in the denominator thing. It's very similar to that. Okay. There's 5 examples. So I can't guarantee any specific amount of space. The example is not 5 pages. The example I'd like to start with is 4 over 7 minus 2i. Just write it. This is very similar to when we had square roots in our denominator. Whenever we have a simplified function, we can't have square roots in the denominator and we cannot have i's in the denominator. So what we want to do is we want to simplify this so there are no i's and no square roots in anything except for our numerator. This is a little bit different, however, than how we did the square root, because then we just multiplied by the square root and we were done. We can't just multiply on I or by I on this one because I have subtraction happening. So we need to multiply by what we call the conjugate of our denominator. The conjugate of my denominator has the same numbers with the opposite sign in the middle. So my denominator here is 7 minus 2i, which means its conjugate is 7 plus 2i. I take that and I multiply it into both my numerator and my denominator. And I multiply straight across. So my numerator is going to be really easy because I'm just taking 4 and multiplying it into both of those terms. So what's 4 times 7? What's 4 times 2i? So I get 28 plus 8i in my numerator. My denominator, however, is not as straightforward. Yes, Eli?
Why is it 7 plus 2?
Because I needed the conjugate because it's going to allow my i's to cancel. So somebody way smarter than us figured out that this works every single time. In my denominator, I'm going to have to FOIL because I have a binomial times a binomial. So let's refresh how to FOIL. I multiply my first terms together. What's 7 times 7? I multiply my outside terms together. What's 7 times 2i? I multiply my inside terms together. What's negative 2i times 7? And then negative 2i times 2i. Negative 4i squared. Okay. What do I automatically notice is happening in my denominator? The i's cancel. 14i and negative 14i zero out. But I still have an I squared.
You know that I squared is negative 1.
I squared equals negative 1, so I replace the I squared with negative 1, which makes us negative 4 times negative 1, which makes it what? Positive 4, which I will then add to the number I had at the front. So what I have now is 28 plus 8i over 53. The last thing I would check for is, can I take a number out of 28, 8, and 53? No. So this is simplified. This is it.
Is this the one from Friday?
Huh?
Is this stuff from Friday?
This is the other half from Friday, yes.
So I have a question on the simplifying. Can we just get the outside and inside part and just do the first and then the last?
Right. If you recognize that, you're fine. Okay. Any major questions, concerns, or issues with that? Are we mostly okay? We're going to do more examples, but is anybody super confused from right here? Okay, let's do another one. Negative 7 over a negative 2i. What is different about this one compared to the previous problem?
It doesn't have a constant.
Heath cannot answer. What is different between this problem and the previous problem?
I like when
There's no addition or subtraction to the 2i.
There's no addition or subtraction happening in my denominator, which means I don't have to multiply by the conjugate. It's even easier than that. What is the only part I don't like from my denominator? The I. So I'm just going to multiply an I into my numerator and my denominator. When I do that, what's negative 7 times I? What's negative 2i times I? Negative 2i squared, which becomes what? Positive 2, because I squared is negative 1. Negative 2 times a negative 1 is positive 2. And then I'm done, because there's nothing that I can reduce out of negative 7 and 2. How do we feel about that?
So that one's a lot.
Those are a lot easier when there's no plus or minus happening, right?
I think that one should be all.
That should be all of them.
I wish math went back like 1-7.
Okay. Any major questions, concerns, or issues? We only have, I think, 2 more examples. 3 more. Okay, we have 4, but we're not going to do all 4.
Yay.
Because I don't think we need all 4. 2 actually would work. Okay. Are we ready? Awesome. I heard that, but I just ignored it. I'm so sorry. I mean, I'm not that sorry, but I am sorry, I guess. I want somebody from those 2 rows to answer this next question. And it has to be a boy. Okay. Do I have to multiply by the conjugate here?
So how do you mean? Just point what the conjugate is. Am I like, okay, if you point to it, I'll know what it is. I don't know what it is.
Conjugate.
Okay.
Same numbers, but with the opposite operation. That's what a conjugate is. So since I had 7 minus 2 i's,
That's 7 plus 2.
I became 7 plus 2 i.
Yeah, we can say that.
Do I need to multiply by the conjugate there?
On the top,
On this one? No, I'm only looking at my denominator. No, why not?
because it doesn't have like a plus and minus.
Okay, I really hope that you're all listening. Say that again.
Because it doesn't have a plus or a minus on the bottom.
I don't have any addition or subtraction happening here, so I do not need to multiply by the conjugate. The number 1 mistake I will see here is that you will see an addition happening in the numerator and you'll assume conjugate. I don't care about what's happening in my numerator. It could be negative 1,000,000. I don't care. All I care about is making my denominator easier to work with. So that's the only thing I look at here. Cole recognized there is no addition or subtraction, so I don't need to multiply by the conjugate. Breyer, what do I need to multiply by though?
7i.
Nope. Am I looking at my numerator for anything right now?
By eye.
Just the denominator. So what's the only thing I don't like there, Breyer? So I multiply by the I to get rid of it. We are only looking at the denominator for these problems. That's all I care about.
So the conjugate can only be like the top.
Only if there's addition or subtraction in the bottom, yes.
So it'll never be the top.
It'll never be the top. No. So there was no addition or subtraction, so we're going to multiply by I over I. I like to do the numerator first because I like to work top to bottom. So what's 7i times I? 7i squared, which becomes what? Negative 7. What is 4 times I? 4i. Over, what's 2i times I? 2i squared, which is what? Negative 2. So then I ask myself, is there anything I can take out of negative 7, 4, and negative 2? Nope, so I'm done. It always changes the sign. Yep. When we have an I squared, it changes. That's it. That's it. How do we feel about that? Is this getting easier the more we do it? Okay, we have one more, and then I will let us be finished.
It's not that hard on there.
So I'm gonna call on you anyway, right?
No, I want it if I know it. It's amazing.
So I have -6 plus 3i in my numerator, and I have 3 minus I in my denominator. Briar, I would like to simplify this. What's the first thing I need to look at?
There's a minus sign on the denominator.
In the denominator, there's a minus. So what am I going to multiply by to simplify that?
3. Wait, hang on.
You're on the right track.
3. We do plus 1.
3 plus I.
I thought the I meant 1 was -1.
I squared equals -1, not I by itself. So when it's just an I, we leave it.
Okay.
Okay? But yes, I'm going to multiply by the 3 plus I. What do we call that? The conjugate. There will be vocab on this test.
We did.
Not a lot of it,
We did out.
but a few random words like conjugate.
That's
Okay.
fun. I know what that is.
So we are going to multiply by the conjugate of 3 minus I, which is 3 plus I. We multiply that into both the numerator and the denominator. I recognize that my numerator is a binomial times a binomial, so I'm going to have to FOIL. So when I FOIL, I start with -6 times 3.
But I thought you foiled the bottom.
We're going to have to do both. Whenever we have a binomial times a binomial, we have to FOIL. So we're going to do both here. What's -6 times -6 times 3? -18. Then I do -6 times I to get -6i. Then I do 3i times 3 to get a positive 9i. And I do 3i times I to get a positive 3i squared. And then over, I'm going to do the same thing for my denominator. 3 times 3 becomes 9. 3 times I becomes 3i. -I times 3 becomes -3i. And -I times I becomes -I squared. Take a second to really process that and make sure you understand where each of those values came from. And then we will finish simplifying. Hannah, what can I do in my numerator to make it easier to work with? Oh, so, okay, so it's plus 3i, right?
Yeah.
And then -3 because 3i squared becomes 3 times -1, which becomes -3. Good. Grant, what's going to happen in my denominator? Okay. Yep. And I'm going to do what with that positive 1? Perfect. Am I finished right here? No, Emily, what do I still have to do? Combine like terms in my numerator. I have 2 whole numbers that I can put together. So what's -18 and a -3? So I get -21 plus 3i over 10. Am I finished? Yes, there's nothing that I can take out of -21, 3, and 10. So this is my final answer.
Wait, how'd you get -3 out of that?
3i squared, I squared becomes -1. So I get 3 times a -1, which becomes a -3. Any other questions? Okay, your homework is on Canvas. If you have questions, obviously I'm here to answer them. You should already have part of your homework done from Friday, hopefully.
This is the same thing Friday, right?
Same thing from Friday, yep. So Finish the homework. That will be due tomorrow. Tomorrow we will start the mid-unit review, which will be due on Wednesday. Wednesday will be your quiz, but your review for the final exam is open right now, so feel free to work on it whenever you can.
Mr. Mayor, I'm on my computer today, so can I try to pull up the PDF?